What's up everyone, welcome back. Patrick here, moving on to the next example in the Unit 1 Advanced Functions test. So in this particular example, we are given three functions and we have to state what the range of each of these functions is going to be. And notice that each of these functions, they deal with a different parent function. So notice in part A, we have the parent function x squared. Part B, we got the square root of x. Then part C, we got the parent function 1 over x, the reciprocal function. Now, different ways you could do this question. You can, if you want, go through the entire transformation process of graphing these, and then you can look at your specific graph and then get the range from there. However, notice in this question, they're not asking us to graph. And so they're just asking for the range. And if you get a question like this, I think it is helpful to try to be able to do a question like this fast in terms of knowing how the different transformation values affect each parent function. Hopefully you're a little bit more familiar at this point with it being the end of the unit, and you can look at these fairly quickly, maybe draw some rough graphs, which we're going to be doing. And then from there, you can see what the range is going to be. So I'm not going to be going through the entire transformation process. I'm going to try to just talk through these and then get the range like that, just from intuition. Because you don't want to be spending too much time on a question like this if they're just asking for the range and then taking time away from the larger questions later on in the tests. For example, when they are going to ask you to go through the entire transformation process to graph a function. So I would just try to think about what the range would be. So let's start off with part A. Now, this is a quadratic, right? And if you think about it, the range of a quadratic is always going to depend on two things. Okay, so if you have a quadratic x squared and it's been transformed, the range depends on two things. It depends on the y value of the vertex, and then it also depends on whether the function opens up or down. And if you remember, what determines that? The a value, right? If the a value is negative, the quadratic is going to be opening down. The a value is positive, it's going to be opening up. Well, looking at this quadratic here, notice that the vertex is what? It's already in vertex form, so it's -4, -1. And then notice that the a value is -3. So that means that this quadratic is opening down. And that right there is already enough information for us to get the range. So this is what I mean. Without graphing it, I could already tell that the y value of the vertex is -1 and the function is opening down. And so the range is going to be basically YER, y is less than or equal to -1. Now, if you were to graph this, let's just make a rough sketch here. -4, -1, that's like over here, right? So we're at a y value of -1, and then it opens down, right? So it has a maximum value of that y value of -1. And so the range would be y is less than or equal to -1. And notice that it doesn't matter what the x value of the vertex is, right? Because this vertex could have been like over here, right? But if it still has that y value of -1 and it's opening down, range is not going to change. Also, whether it's stretched or compressed, right? That's not going to matter either. So only two things affect the range specifically for a quadratic: the y value of the vertex and whether it opens up or down. And so you should be able to look at a function, and then from there you could tell, okay, what's the range going to be without even having to graph it. Now, if you want to make a quick sketch, right, just to kind of get more confidence in your answer and to just visually see it, that's fine. But again, you want to be able to get these characteristics of these different parent functions in a quick way in case a question like this comes up where it's not going to be worth too many marks, but you want to get through it fairly quickly. Yo, what's up? Quick little intermission here. Wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order, and I'd recommend doing so because lots of concepts carry over from one video to the next. Also, for lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help and tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. We can discuss availability and then we can book a session. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. Moving on to part B, we have the square root function. Now, the square root function, the range, is also going to be affected by two different things. It's going to be affected by the C value, the transformation, so that's always going to be the value at the end here. So in this case, it is -3. And then it's going to also depend on the A value, or whether it's going up, whether it's increasing, or whether it's decreasing, or whether it's been reflected in the x-axis. Right? It's going to depend on the A value, which in this case is -5. It's only going to depend on those two values. It's actually the exact same thing as the quadratic. The quadratic depended on the C value of -1 and then the A value. And more specifically, not just the A value, but the sign of the A value, if you want to be a little bit more specific. Right? Because the C value, like if you remember a square root function, the parent function looks like this, right? So the C value is the amount that it's been vertically translated up or down, right? So we have a -3, meaning that it's been vertically translated down 3 units. Now I know it's also been translated 4 units to the left, but as I mentioned with the quadratic, the horizontal translations, they don't affect the range. They do affect the domain for a square root function, but they don't affect the range. Okay, so we know that the this square root function in particular is going to start at a y value of -3, and again, it's going to be here, right? So it's going to be at -4, -3, and then notice that the A value is negative, so it's been reflected in the x-axis, or it's going to be decreasing like that. And it's actually, because the K value is negative, it's actually not going to be going this way, it's actually going to be going this way. But here's another thing, notice that the sign of the K value doesn't affect the range. So whether it was going this way, whether that K value stayed positive, or in this case, it's actually going to be negative, so if it's going this way, notice the range for both of these is still y is less than or equal to -3. So the fact that that K value is negative, it doesn't affect the range. It is going to affect the domain, doesn't affect the range. The range of a square root function only depends on the C value, which is -3 in this case, right? How much has been translated up or down, and then the sign of the A value, not the K value, because the A value is what makes it go up or makes it go down, and that's what affects the range. Okay, so in general, if you were to graph this, right, it would look roughly like that over here. But again, you should be able to look at these and then tell what the range is going to be. And so the range in this case is going to be YER, y is less than or equal to that C value of -3. If this was +5, this would be greater than or equal to -3, right? If this -3 was a +2, then the function would be starting up there, and it will be less than or equal to positive 2. So the range, again, for a square root function depends on the c value and the sign of the a value. And then moving on to part C, we got the reciprocal function 1 over x, and it's been transformed. Now with 1 over x, if you remember from the transformation lecture videos, which I'm assuming you've watched, when you transform 1 over x, it's going to take this format, right? Like that. And if you remember, the d value is always the vertical asymptote, and the c value is always the horizontal asymptote. And basically the domain always, and the range, the formats of them for a reciprocal function is going to be XER. X cannot equal whatever that d value is. The range is always going to be YER. Y cannot equal whatever that c value is, whatever that horizontal asymptote is. Well, notice the c value in this case is positive 2 for this function. And so we know that the range is just going to be YER. Y cannot equal to positive 2, the horizontal asymptote of positive 2. And that's it, right? So we didn't even have to graph it, right? So you should remember at this point, domain and range for a reciprocal function always has this format. Domain x can't be the vertical asymptote, which in this case is -5, okay, but they're not asking for the domain. The range is always going to be YER. Y cannot equal the horizontal asymptote, which is always the c value, which is positive 2 in this case. It doesn't depend on whether the a value is positive or negative, okay, like it does for the square root function and the quadratic, because you could have the reciprocal function looking like this, but if you reflect it, right, then it's going to look like this. Notice the range is not going to be affected. The horizontal asymptote is still going to be the same. Vertical asymptote is going to be the same. So whether the a value is positive or negative, or the k value is positive or negative, doesn't affect the domain and range for a reciprocal function specifically. The only thing that affects those is the d value and the c value. Okay, so the range for this last function is YER. Y cannot equal 2. Right, so as you do these, as you start graphing these different functions, pay attention to what's specifically affecting the domain and range for each of them. Sometimes the domain is always staying the same, like for an x squared function, it's always going to be XER no matter how you transform it, right? But for these other functions, domain and range get affected in certain ways, and I've mentioned how in the lecture videos as we've gone through the process. But just be on the lookout for questions like this where you should be on the fly, be able to get characteristics pretty quickly without going through the entire transformation process and then looking at it visually, because sometimes that will take lots of time. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.